Hello and good afternoon, my dear kids. Welcome back once again to this short tutorial video for class 7 students. Okay, under the topic maths. Okay, since we are doing the linear equations in one variable, so this will be the continuation of that. Okay. For those who haven't gone through the previous video, please go through the previous video as we have discussed all the basics on the previous video. Okay, or else it will be. The terms will be new and the steps will be unknown to you. Okay, so exercise 12b, what I have chosen is from exercise 12b, question number 1. I have taken question number 1 as 2x divided by 3 equals to 8. Now what do I see again here? Variables, a constant term in the division relation. What did I say? When a division goes to other side, what happens? Multiplication, isn't it? This 3 will go to other side, it will multiply 8. So see, 2x equals to 8 into 3. It's also known as cross multiplication. Okay, and see now, so before multiplying, so what do I see here is I got the coefficient of x is 2, isn't it? So instead of multiplying, if I take 2 to the other side, see what happens is when you multiply any number, the number will obviously it will grow, isn't it? That is, the number will be bigger. So smaller the number, easier to handle, isn't it? So that is why instead of multiplying, what I did was, see, simply I have taken 2 to the other side in order to check whether they can be cancelled or not. Okay, so and what did I see here after that? Yeah, I know that it can be cancelled. 2 1 times 2, 2 4 times is 8. See, and what did I see here now? The numerator is 4 into 3, so 4 into 3 is 12. So we are done here. The relation of 2 in here was multiplication, and as we have already discussed on the previous video, what happens when multiplication goes to other side? So division. So that is what happened here, division. Okay. For question number 2, what do I have in question number 2 is, see, x by 2 plus 4x minus 18. Okay. So actually this one, both the sides, on the left hand side we got variables, that too in the fractional forms, isn't it? So what are we supposed to do? It's addition of fractions. Okay, and how do we do that? Addition of fractions, first we need to take the LCM, isn't it? So that is what I have done here. And what I know, the denominator for 4x is 1, isn't it? So that is what I have taken LCM. See, now I know how you add the fractions, isn't it? It's just that these are in terms of variables. Okay, the process will be same. So 2 1 times is 2, so 1 multiplied with the first numerator plus the second numerator. The numerator is 1, so 1 2 times is 2, 2 went up. So 1 into x is x, plus 2 into 4x is 8x, equals to 18. The other side is 18, so equals to 18. Now what happens? This division goes to other side, it becomes multiplication. So 2 went to other side, multiplication. See, now what do I see in the numerator? X plus 8x, like term. So x plus 8x is 9x, so 9x. 18 into 2, I haven't multiplied. What did I say? Isn't it? So I haven't multiplied. I need to check whether they can be cancelled or not. So 9, I know, because the coefficient was 9. I cannot get coefficient as 9, isn't it? So 9 went to other side, became division. So am I good luck? What did I see? I can cancel the terms. So 9 1 times is 9, 9 2 times is 18. So what do we get in the numerator? X equals 2 into 2, that is 4. Denominator is 1, no need to mention it, isn't it? Okay. Similarly, for question number 3, we have here is n plus 3 by n 4 equals to 14. Now again, the variables on the left hand side, but they are addition of fractional forms first. So I have taken the LCM. So I guess now you know how to do the LCM of it also. Fractional forms, the variables as well, isn't it? So the 4 denominator will be 4. The denominator for first term in here is 1. So 1 4 times 4 into n is 4n plus 3n, again is 14. Again, the denominator goes to other side because multiplication, cross multiplication, as I have already said, because it's in the relations division. Division goes to other side, multiplication, isn't it? So 7n equals to 14 into 4. So I haven't multiplied the term, see, in order to check whether they can be cancelled or not, because still I got 7 as my coefficient. Okay, so now finally n equals to 14 into 4 divided by 7, and what do I figured out? That they can be cancelled. 7 1 times, 7 2 times. Now 2 into 4, that is 8. A variable, a constant term separately, and we are done here. Okay. So moving on to the next one. What we have here on question number 6 is 2u by 3 minus u by 5 equals to 15. Again, subtraction of fractional forms. So always at first take the LCM. 3 and 5 in the denominator, the LCM is 15 obviously. So 3 5 times, so 5 3 times 15, so 3. Numerators I have kept it as it is. Now 5 into 2 is 10u, minus 3 into u is 3u, divided by 15. Now what happens? 15 goes to the other side, cross multiplication. Division goes to the other side, multiplication, so multiply. 10 minus 3u, 10u minus 3u, like term, so it's 7u. The coefficient of the variable is 7, so we need to get rid of that as well. How will you do that? Its relation is multiplication, goes to the other side, division, so 7. See, I haven't multiplied the term, so in order to check. So, and my good luck, here too I got the terms that can be cancelled. So 7 2 times 14. So u equals to 2 into 15, that is 30. Okay. For question number 7, what do we have here is, see, we got fractional form, 3 fractional forms, all with the variables and on the left hand side. So what are we supposed to do first? We're supposed to take the LCM, isn't it? So 2, 3 and 4. Once you take the LCM, you'll get 12. 2 6 is times 12, so 6 to the first numerator. 3 4 times 12, so 4 to the second numerator. 4 3 times is 12, so 3 to the third numerator. So 6 into x is 6x, 4 into x is 4x, 3x into 3 it's 9x, and here I have directly taken the denominator to other side as well, so multiplication. And now what do I see here is 6 plus 4 is 10x, 10x minus 9 is 1x, isn't it? So 1x, so therefore I have multiplied the term, because there is nothing, no coefficient out there other than 1, so I can take the other side. So that is why x equals to 312 times is 36. Okay. Yeah, this question is in the decimal form, so that's what I have done here. Okay, simple. It's nothing but it's same but simple. It's in terms of decimal, so that is what I have done here. So what do I say on the left hand side? A variable, a constant term equals to, and a variable with a coefficient in decimal form on the right side. So what are we supposed to do? Simply take the decimal to the other side, isn't it? And the constant term to the other side. So once you take minus 1.5 to the 0.5 to the other side, 0.5y to the other side, what happens? Plus, it's plus, and the sign is plus, change to minus. This 7 will go to the other side, and it will also change from its sign from plus to minus. See, they have switched their position, their places, their sides crossed the border, so therefore the sign changed. Now 1.5 minus 0.5, it's 1 actually, isn't it? So 1y equals to minus 7. So 1y equals to minus 7, or y equals to minus 7. It's same thing, isn't it? So that's why we are done here. Okay. Now in this one, it looks like a bit complicated one, isn't it? But actually it's easy. Okay. So question number 10, what we have here is x plus 3 divided by 2, and we have minus in here, minus 3x plus 1 divided by 4 equals to 2 into x plus 2 divided by 3 minus 2 on the right side. Both the left side and the right side, we got variables as well as fractional forms, that too with subtraction relation. So what I have done here, I have subtracted from both the sides, see, at the same time. So this 2 and 4, the LCM is 4. 2 times is 4. That 2 has to multiply both the terms, so therefore I have kept it at front and the binomial at the second within the bracket. Minus 4 1 times is 4. So actually it will be multiplied with 1, but still I am using the bracket. Why? Because of this negative sign, remember. So negative 3x plus 1. Okay. Equals to the other side. The denominator was 1. So 3 is LCM. The first numerator remains same because 3 1 times. So even if you multiply this with 1, you will get the same result, isn't it? So that is what I have not written into 1. And minus second numerator 2, denominator is 1. 1 3 times is 3, so 3. Okay. Now let's open up the bracket. 2 into x, you will get 2x plus 6. Minus into plus is minus 3x. Minus into plus is minus, so minus 1 divided by 3 and 4 in the new denominator equals to 2 into x is 2x plus into minus. Minus 2 times is 4, minus 2 3 times is 6, so 6 divided by 3 in the denominator, the other side as well, left right hand side. Then in the numerators, what do I see is 2x minus 3x, like term. So 2x minus 3x, opposite signs is subtracted, like terms, opposite signs subtract sign, a greater number for 3 is greater, so it is minus 6. Okay, and 6 minus 1 is plus 5, so 6 minus 1 is plus 5 divided by 4, see, equals to, from this side 2x, just one variable, 2 constant terms, so 2x constant terms with same signs are added, we know sign remains same, so it is minus 10. Now we cannot approach any further, isn't it? So in that case we have to cross multiply the terms. See, multiplication, division goes to other side, multiplication, similarly this division goes to other side, becomes multiplication. So that is what I have written. See, 3 within bracket minus x plus 5, because this 3 will multiply both the terms. Similarly this 4 has to multiply both the terms, so 4 within bracket 2x plus 10. Now after that, see, 3 into minus 6 minus 3x, 3 into plus 5 is plus 15, equals to 4 2 times is 8x, minus 40, 4 10 times is 40, isn't it? So now, see, now what to do? See, yes, what you can do is, you can either take variable to the other side or the constant to the other side, isn't it? We are doing the variable to the left side and constant to the other side, isn't it? But in this one, see, I have taken variable to the other side. Why I have taken variable to the other side is because the variable with a bigger number was on the other side. Okay, so that is what I have followed that. The variable with the bigger coefficient, followed that, I followed that and taken 3x to the other side. So, and 40 to the other side. You can do this as well. Because since it's an equal to, as I have already said, equal to means equal, isn't it? So, 15, this minus 40 became plus 40, see? 8x was already there, minus 3x became plus 3x, see? Now 15 plus 40 is 55. Even if you take 8x to other side, it will be same. Okay? Now, the sign will be different, minus, it will come in minus, but both sides it will be minus, so you can cancel the terms. Okay? Minus the term and you will get the same result. Okay, so 15 plus 40 equals to 8x plus 3x. 8x plus 3x is 11x, see, 15 plus 40 is 55. Now 55 equals to 11x, and I have written 11x equals to 55. Here what I have done here is, see, 11x equals to 55, and 55 equals to 11x, and 11x equals to 55 I have written on the other side. What I have done here actually is, I have changed the place, isn't it? See, 11x, actually it was on the right side, and I have taken it on the left side. And this one is on the left side, and I have taken it on the right side. But I haven't changed the sign, isn't it? Now why I haven't changed the sign here is because when there are monomials and monomials on both the sides, remember this one, this is very important. When there are monomials and monomials on both the sides and you are changing the entire terms, see, like from the entire side, monomial from one side to complete monomial to the other side and complete monomial to the other side, at that time you may neglect changing the sign. Okay, or what may happen is, suppose, see, if you take 11 to the other side, if you take minus 11, if you take 58 to the other side, minus 55, so monomial and monomial, 55 and 55, so this you can cancel here as well. If both sides are negative, monomial, or even if you want to keep it, see, and finally what happened here, x equals 55 divided by 11, isn't it? Or if you have kept the negative sign as it is, see, minus 55, minus 11, now what will happen? The fractional form. So minus and minus will be cancelled, isn't it? 11 times is 11, 1 times 11, 5 times 55, that is x equals to 5 is our answer. Okay? Okay, so few more sums, okay? So for question number 13, again, decimal form, I have chosen decimal form. So it's simple one, isn't it? See, 2 decimal forms with variables on the left side and 1 decimal form with a variable on the right side as well. So what do I need to do? I need to take this to the other side, as simple as that. So first of all, I have added these terms because they were like terms, 0.26, 0.09, 0.26, 0.09. I have added them up. They give me 0.35x, taken minus 0.45 from right side to left side, so it is plus 0.45 divided by x equals to 8 was already there on the right side, so it remained as it is. Now after adding these two, how much I got? I got 0.80, x equals to 8. Now 0.80 or 0.8, it's same thing, isn't it? So that is what I have taken this term to the other side. See, x equals to 8, because the coefficient is 0.80. Remember, the only coefficient I can left with x is 1, isn't it? So 0.8 to the other side, so multiplication goes to the other side, division, so 0.8. Now what happens when you remove the decimal? 10 will come up, isn't it? This is what we have done on the basics of decimals, okay, in the previous classes. Okay, so it is x into 10 divided by 8. Now see, 8 1 times is 8, 8 1 times is 8. The denominator is 1, numerator is 1 into 10, that is 10. So we got value of x as 10, x equals to 10, and we are done here. Okay, so the final sum for today here we have is, see, x minus 10% of x equals to 27. Okay, x minus 10% of x equals to 27. So first of all, we need to convert it from the language to the equation form, because there are language like percentage and off and all, isn't it? So percentage means what? Simple, 10 divided by 100, isn't it? Off means into, so into x. That is what I have done in the second step. See, after that, what do I see? This side, the left side, both the terms variables, isn't it? So it's easier for me, because the right side is only we have is constant term, so it's easier for me. And what do I see here? 10 and 100. 10 divided 100, make it cancelled. So 10 divided 100 is 10, or you can simply cancel 0 and 0 as well. Okay, so x minus 1 by, this is what we have done in decimals part as well, fractions and converting decimals and all. So x minus 1 into x is x, denominator is 10, equals to 27, the other side. See, now we got subtraction of fractional forms. So how will you do that? Taking the LCM, the denominator is 1 out here, so 10 again, the LCM, so 1 10 times is 10, so 10x minus 10 1 times 1 into x is x, so equals to 27. Now what happens with this 10? This will go up, isn't it? Multiply with 10, cross multiplication, as I have already said. So 10x minus x is 9x equals to 27 by 10. Now this 9 also will go to the other side, because the coefficient is, we cannot keep coefficient as 9. So go to the multiplication, goes to division. I haven't multiplied because I cannot want my number to grow, isn't it? I need to check whether they can be cancelled or not. So, and luckily here also I got terms that can be cancelled. So 9 1 times is 9, 9 3 times is 27. So now see, 3 into 10 times is 30. The numerator is 30, so x equals 30. Denominator is 1, no need to mention 1 in the denominator. We got variable with coefficient 1 on one of the sides, a constant term on another side, and we are done here. Okay, so I hope you kids have understood today's lesson. Okay, so what I want you to do is, I want you to do the remaining sums as your homework. Okay, if you have any problems, please do let me know. Okay, till then, stay safe and stay tuned in for more videos. Okay, bye bye.